Okay, so now I want to talk about what are called unit vectors. Okay, we're gonna need to understand unit vectors as well as vector components in order to understand how to add vectors algebraically. Okay, how to add vectors algebraically. So let's first understand what a unit vector is. All right, a unit vector is a vector that just has a magnitude of 1, and it just tells you the direction along the x, y, or the z axis. Okay, so for example, with the x-axis, we associate a unit vector I hat. Okay, so the length of this vector, is 1. Okay, so it's 1 along one unit along the x-axis, 0 units along the y, and 0 units along the z direction. Okay, so this length is just 1, and we associate I hat with the x direction. Similarly, with the y direction, we associate the unit vector j hat. Okay, so the length of this vector is 1, but since it's along the y direction, okay, so 0 along x, 1 unit along y, and 0 units along z. And with the z direction, we associate the unit vector k hat. Okay, so we read this as k hat. Once again, the length is 1, but in this case, it's 0 along x, 0 along y, and it's 1 unit along the z direction. Okay, so these are unit vectors, and their physical meaning is essentially that they have no other physical meaning except that they tell you the direction along the x, y, and the z axis, right? And they have a magnitude of 1. Okay, this will become more clear once we understand vector components. Okay, so the use of this will become more clear here. Right? So now let's discuss what vector components are. So what is a vector component? So what you see here, I have this vector A. Okay, I've drawn this vector A, and this vector makes some angle theta with the x-axis. Okay, so the vector components of this vector, when we talk about vector components, it's just the projection of this vector along the x and along the y direction, the projection of the vector. Okay, so the projection of the vector along the x direction we call ax, the vector ax, and the projection of the vector along the y direction we call the vector ay. Okay, and together ax plus ay give me this vector a. Okay, so I have transported this projection along the y direction to the head of ax. Okay, I've brought the tail to the head of ax here, and I've drawn this vector ay here. So the sum goes from here to here. So this vector a is given by ax plus ay. It's the sum of these two vectors. Okay? So these two vectors have a length. That length is given by ax. Okay, and since ax is along the x direction, I can write this vector as ax I hat, because when I multiply by I hat just has a magnitude of 1. So I don't actually change the length of the vector. Okay, I don't change the length of this vector ax by multiplying by 1, right? So this I hat is just telling me that this vector ax is along the x direction. Okay, and it has this magnitude, whatever the number in front of I hat is. Okay, similarly, this vector ay, right, I can write as ay, the length of the vector, times j hat, where j hat is telling me that this vector is along the y direction. Okay, so it has a magnitude of ay, whatever this length is, and this j hat is telling me that it points along the y direction. Okay, so together I can write this vector as axi hat plus ay j hat. Okay, so this is the x component of the vector, and this is the y component of the vector. Okay, so this is the vector form of the vector A. Okay, this is the vector form of the vector A. Okay. When I say vector form, I mean the written in terms of its x and y components. All right. Okay, so I can always write a vector in terms of its x and y components. All right. Now, let's say that you know, let's say ax and ay are known. Okay, ax and ay are known, but you do not know the length of vector A. So how can you find the length of vector A provided that you know the components of A? Okay, you know the components, but you do not know the length of the vector A. So how can you find that? So that is going to be just given by the Pythagorean theorem, because this is a 90-degree angle here. Yes. So this is 90 degrees. So if I know this side, I know this side, and then I can determine this hypotenuse. So that's just a squared is going to be ax squared plus ay squared. So then a, the magnitude of a will just be the square root of this right hand side. So that's going to be ax squared plus ay squared square root, right? That's if I know ax and ay, I can find the magnitude of the vector A. All right. But what if I know A, I know the magnitude of vector A, and I know this angle theta. Okay, so this is known, and this length is known. This angle is known, and this length is known, but these two components are not known. So how can I find ax and ay? Okay, provided I know this and I know this. Okay, so if you look at this triangle, and if you determine the cosine of theta, the cosine of theta is the adjacent side over the hypotenuse. Yes. Okay, so adjacent over hypotenuse, so that's going to be ax over a. Since I know a and I know theta, if I know theta, then I know the cosine of theta. So then ax is just a cosine of theta. I just multiply both sides by a, and I get that the x component is a cosine of theta. Similarly, if I want to find the y component, this is y, then the sine of theta, I know, is the opposite side over the hypotenuse. Yes, so remember SOHCAHTOA, okay? Let me write that down. Okay, SOHCAHTOA, so remember this. So the sine is opposite over hypotenuse. So in this case, I have ay over a. Once again, a I know, theta I know, so that means sine of theta is known. Then ay is a sine of theta. Right, multiply both sides by a, and you get ay is equal to a sine of theta. Okay? So this is how I can find the x and the y components, provided I know the length of the vector A, and I know this angle theta that this makes with the x-axis, the vector makes with the x-axis. Okay, so I can always find the components, provided I know those two things. Okay, so now we are in the position to understand how to add and subtract vectors algebraically. Right? So let's say now that I want to find the vector r algebraically, which is given by a plus b. And I'm assuming here that a and b are in the xy plane. Okay, so we're ignoring the z direction right now, just to keep things simple. But it will be the same thing. If you had a vector in 3 dimensions, right, it'll just have one more term there. Okay, but I won't talk about that right now. But let's just say that these are in the xy plane. So I want to find a plus b. So a plus b in this case is going to be, I write this in vector notation, and I write this in terms of its components, and I write this in terms of its components. So this is going to become axi hat plus ayj hat. So that's my vector a plus bxi hat plus byj hat. So that is my vector b. So after this, I combine the like terms, namely the I hat with the I hat. So the I hat factors out. So this is going to give me ax plus bx I hat plus ay plus by j hat, where these are just numbers. Ax, bx, this is just a number. These are just numbers, and similarly, ay and by are just numbers. Okay, so this will now give me the vector r. It's a vector, so it has to have an x and y component. So the x component of this vector r is just this sum, and the y component of the vector r is just this sum. So I can write this, the vector resultant vector r as rxi hat plus ryj hat, where rx is given by this and ry is given by all of this. Okay, so this is how you can add the vectors algebraically. If you want to find r, but this time r is a minus b, okay, if r is a minus b, then I will write a as axi hat plus ayj hat, and then I have this minus sign, then b is bxi hat plus byj hat. Okay, I distribute this minus sign inside, so this will give me axi hat plus ayj hat minus bxi hat minus byj hat. Yes, I combine the like terms. Yes, ax minus bx I hat, so this gives me that, and then ay minus byj hat. Okay, so this will give me the vector a minus b. Okay, so this is how you can add the vectors algebraically. So we'll make these ideas more concrete in class.